Hi, welcome back for data collection part 2. Today we're going to be looking at random sampling. So there are ways of sampling that aren't random, but random is generally seen as being the best way to do things, and is the best way to do things. Can be a bit more expensive, so that can be, whenever you're looking for a disadvantage, that would be it. There are 3 forms of random sampling we need to know about. They're up there. Oh, this is a challenge, isn't it? How do I do that? They're up here. Simple random, systematic, and stratified. So you might want to try and write down those 3 terms down and identify anything you feel you might know about them now before I go through it with you. Right, so we're looking at random sampling, as I said. Today's biscuit is a chocolate chip. Now, there's a reason for that. What I thought we might think about is, if you wanted to test your biscuits, if you were producing chocolate chip biscuits, what might be the thing that you needed to make sure was quite consistent? And I think you're possibly thinking the way I'm thinking, that we need to make sure we've got the right number of chocolate chips, or a certain number of chocolate chips in our biscuit. Too many, and we're shelling out too much chocolate and not cutting down on our profit margin. Too few, and people start to complain that it's not a proper chocolate chip cookie at all that you're trying to foist on them. So how would we do that? We would want to test a few, wouldn't we? So if I had 50 biscuits, one thing I could do, and they'd all come out of the pot, whatever, they come out and they're all lined up. One thing I could do is I could test 5 of them, and I could number all my biscuits, and then I'd use a random number generator, which you can do on a calculator, by the way, but you don't have to know how to do that for the purposes of this. You just have to know that there is one. And you could randomly generate the first 5 numbers that come up, and those biscuits you would have a look at. So that's what simple random testing is, and often the best way to describe it is just to say how you would do it, and sometimes that's what the question asks anyway. So you want to write something down like this: use a random number generator to select the desired number of items from a numbered list. So the desired number of items is your sample size, and your numbered list is your sampling frame, if you remember that from last time. Okay, now one problem you might have if you've made your chocolate chips. I don't know how they make chocolate chip cookies, but I imagine they have a great big pan of all the biscuity stuff, and then they've chucked in the chips, they've stirred them all in, and then they pick them all out, and then they've lined up their 50 cookies in a row. Now what may well happen is the cookies that have come from the same part of the pot that were close to each other are probably going to be quite close to each other in the line. So if I was generating my number generator and it had given me, I don't know, 4, 15, 18, 19 and 36 as my 5 cookies, you may notice that 3 of those have ended up being quite closely lumbered together. So what a systematic sample looks to do is to get rid of that possibility of clumping together. So what you do is you use a random number generator just to find your first one. So if you're going for 50, if we've got 50 biscuits and we want 5, it's 1 in every 10, isn't it? So what we would do, because it's 1 in every 10, we would select one of the first 10 using a random number generator, and once we'd got that, we would just take every 10th one after that. So if the first number that came up was, say, 4, as we'd had there, we would then take 14, 24, 34 and 44, and that would stop this problem that we were possibly facing before of having too many from one part of the pot and not enough from somewhere else. They often like to ask about systematic sampling in things, so see if you can write your description down before you see mine of how to do it. It's not an easy thing to do. I would always suggest coming up with an example of the size that you want. So I've started, if a sample of size 10 is desired from a population of 200, begin with a numbered list and using a random number generator, select one of the first 20, then take every 20th from that point in the list. E.g. 9, so that's your random number generator has done 9, and then 9 plus 20, 29, 49, 69, and so on. If you double check that, there are 10 different data points selected there. Great, so now we've just got one left to go, which is stratified, and that probably wouldn't be so handy for Biscuit. So I'm going to tuck into this Biscuit and ask you to think about what problems you may have if you were going to ask the opinions of everyone in your school year and you were just to use a systematic thing, and you wanted the opinions of boys and girls and how in equal numbers, and how you might manage to sort that out. So in a stratified sample, it's still taken randomly, but certain desired types are kept separate, and proportionally the same number are taken from each. So for example, if you happen to have twice as many girls as boys in the year and you wanted a sample of 30, you would be making sure that you made one separate list of your girls and your boys, and you took twice as many girls as you did boys, because then that would be fairer because there were more girls in the year. Have a go at writing that one down. So here I've come up with the population is divided into groups before randomly drawing samples from each strata in proportion to how they occur in the whole population. Right, and next we'll have a little look at a few examples of how to do this. Here's our first example. Jot it down and have a go before I explain it. So the first thing you've got to make sure when you're doing a random number generator that they haven't put is that you need to number a list of the members of the yacht club, and then you want to use a random number generator to select 12 of them at random, and that if a number comes up more than once you ignore it and go on, but that will be assumed. So you just need to put in that you then use the random number generator to select the first 12 numbers that you can. So I've gone for use a calculator to randomly generate 12 numbers between 1 and 100, then select the corresponding members from the numbered list. Second question, explain how the committee could use a lottery sample to take a simple random sample of the members. Well, what's meant by a lottery sample is basically numbers from a hat. So you need to write down something about going through the process of writing all the numbers on bits of paper, screwing them up and putting them in a hat. So I've just gone for writing down the names of all the members on separate pieces of paper, put them all in a hat and draw out 12 pieces of paper. Maybe I should say without looking at them beforehand, and then select the names from those pieces of paper. That should be fine. Next question. Take a minute or two to write this whole question out and then have a think. So because you've got different ages and it says that they're thought to have different opinions for different age groups, it's obviously important to have that represented proportionately across, so it's stratified sampling that we need, because sampling's in the question there, you just need to write stratified. And the next part is explain how he could use this method to select a sample of workers' opinions. So this is where we make sure we've got the right fraction going on. So we've got 3 different groups. So for 18 to 32, we will have 75 out of 75 plus 140 plus 85. What does that add up to? That's 300. So the number of workers in that group we've got over the whole population, and then the sample size is 80, so you multiply by that size. Just as if you wanted a percentage, 75 as a percentage, you times it by 100. Because it's not a percentage we want but a fraction out of 80, you just smack that in and see what that gives you, and that gives us 20. Now if you haven't done the other two sets, pause the video and do that before you look at my solution, which I'm about to reveal. So all I've done is change the amount, the numerator that I want, and in my calculator I can just go back through, change that number to 140, press equals, and oh, what does that give us? S2D 37.3. And 48 to 62, so that'll be 85 out of 140 times 80, which is 22 2/3. So then we would then need to say, in order to explain, so that you're going to need to get a numbered list of the three groups of workers, then use a random number generator to randomly select 20 from 18 to 32, 37 from 33 to 47, and if we round that up to 23, because it was 2/3, 23 from there, that will get it. So I'm not going to write all that down, I'll leave that to you to do. So it's going through the same thing again about having three numbered lists and using a random number generator to randomly select 20 from there, 37 from there, and 23 from there. But this working is part of your explanation. Next up, you may be asked questions about the advantages or disadvantages of various sorts of sampling. Next lesson we will be doing non-random sampling, and this advantage that we've got up here for simple random sampling or free of bias, that is true for all three of these. The whole point of randomness is it's not biased, but it doesn't mean that you won't get something that might look a bit biased. So amongst these disadvantages, and you want to take your time to pause this and copy this table down, because it is very important. So all of them are going to need, you'll notice it says a sampling frame is needed there and there. You would still need a sampling frame in the stratified sampling, but because there are other disadvantages, because it's more difficult to take a stratified sample than the others, they haven't bothered putting it in there, but that should also be in here. So if you've got a sampling frame and your numbered list hasn't got it all put into the distinct strata that you want, whether that's boys and girls, or I don't know, managers and those who are being managed, things like that in a company, then that's a difficulty, because you're then going to have to go through and reassemble your sampling frame. This is an interesting one. Systematic sampling, the whole point of it is to stop things being, remember we were talking about the cookies and things all being similar, being put together. But if the person who's put together your sampling frame has done it in a way that is not random, so it might already be male, female, or it may be families all together or something, it may even not necessarily deliberately produce a bias that pops up. So there may be some kind of rhythm in the way that the data has been set up, that taking every third or every fifth or every 10th might unfortunately mean that some are more or less taken. Okay, anyway, we're going to move on now to, we've just got a couple of questions I'd like you to have a go at in the old pause, copy it down, have a go at it, and then compare with my answer before we're done for today. So, a factory manager. You've been doing your own reading for some years now, so I'll let you read that. Pause the video and see if you agree. So how could you take a systematic sample? Well, there's generally 3 marks for this. So the first mark is going to be for making to get or assemble a numbered list of the 480 workers. So that would be one part. Now 480 divided by 30 is 16. So randomly generate a number from 1 to 16, e.g. 13, then take the next 30 at spaces of 16. So e.g. 13 plus 16 would be 29, plus 16 would be 45, etc. And that's done it. So you've got 3 elements there. You need your numbered list, you need to randomly find the first one, and then take them at periodic spaces. What people tend to do is just talk about the periodic spaces and often forget the first 2 marks, which are not that difficult really, just need to think about it. Okay, final question, here you go. Right, how could you take a simple random sample? You should have something like this. Okay, so numbering the list of all 370 members, using a random number generator to get 30 numbers, then taking the names from those positions in the list. You've got to be very, very careful about how you do it. Maths isn't just about being able to do lots of really, really difficult procedures. It's about explaining how you do it as well. Communication is very important. State one advantage of stratified. It means, oh, and I didn't put a disadvantage down. So the disadvantage would be that you're probably not going to get all of the different sports in the exact proportion at which they are in the club. I'm not going to write that down, but you should write something down about that. You may well not have the right proportions of the different sports. So finally, using stratified sample, this is what you should have. And we get this. So it's all the same except the right number in the fraction. You'll notice it's slightly poor on the squash, because when we've rounded, these two have both rounded up a bit, and the squash is almost 8.5, but it's had to go down to 8 to make the 30. But you always, that's as fair as it can be. Okay, so that is random sampling. Look forward to next week, folks, when we start to have a crack at non-random sampling, which don't tend to be such good methods, but they are faster and therefore quite often used. And they're ones where people quite often lose marks because people don't really concentrate on them. They know stratified sampling is important because that's where we've got the real bit of maths in terms of a calculation, but we do need to do all of this, and it's by going over it again and revising it, and not just listening to it but writing it all down, that we get there. Okay, cheerio.